Right, okay, good afternoon, Unite. Welcome to this session on 3D trigonometry. If you've just joined the session, we just very briefly talked about the task this week. We're going to quickly go through some 3D trig examples. Make sure you've got a calculator with you and something to write on to be able to take part in the tasks and the questions that we do. And then on the VLE, the task that's been set is a worksheet for you to complete on some 8 questions on 3D trig. And then you can mark your answers, take a photo of your marked answers and upload that back onto the VLE by Friday. Right, there's the first question is just this little one at the bottom here, which is a question which says, which is bigger? What is bigger? The value of A, B, C, or D. And you've got 4 little triangles there. And I'd just like you to spend a couple of minutes. Don't matter what order you do them in. You don't have to do much working out. And as soon as you've jotted down and think you found which is the biggest value, could you write the letter for the biggest value into the chat box, please? So I'll give you a few minutes. It's going to take you a few minutes, isn't it? Because you're going to need to do all of them, essentially, aren't you? Before you're able to tell me which one is the biggest value. Mixture of skills, Pythagoras, and also SOHCAHTOA is involved here. And there's finding lengths of sides and there's finding an angle as well. So it's a big mixture of tasks and questions. Mr. Hawthorne, is that you talking to Finn rather than me?
Yeah, no, it's not you, sir.
Oh dear. Okay.
He's just having a bit of trouble hearing, and I think it might be because he's on a school computer.
He's just walked past the door about 3 minutes.
I was going to say, you could just go and listen from the outside.
yeah, exactly, yeah. Are you in school this week?
I'm in on Wednesday and Thursday. I've got Year 10 Wednesday, and then that tutor thing on Thursday.
What's your tutor group? Year 8.
8F1, yeah.
Right. Okay.
So yeah, I've got that. Are you all week or?
Yeah. Year 10s all week. I think I've got a couple of Year 12s as well in the afternoons this week.
Sure.
2 more weeks. Can't believe it's 2 more weeks of summer holidays, can you?
I know.
Amazing. Right, I haven't got any answers yet. Your task that you're doing at the moment is trying to work out which one's bigger, A, B, C, or D.
Isabel has just come in and said D.
Okay. Let's see if anyone agrees. Just give everyone another 30 seconds or so. And then we'll quickly work through them and then get on to the main bit today, which is the 3D trig. Right, I'm going to do really brief workings for these. It's not the workings I think you do, but let's just see if we can kind of write down the smallest amount of workings possible that would still give you enough marks to get the workings marks in an exam. So let's go through them. A, first of all, A is a Pythagoras question because you've only got missing sides and it's a shorter side. So I think the workings could be as simple as 45 squared minus 29 squared. to give you an answer of 34.4093, etc. B, I think this is going to be a trig question, a Socoterra question. I think we have got the hypotenuse and we've got the adjacent. And the hypotenuse and adjacent tells me it's the cosine trig function. We're trying to work out the adjacent, so I think we're going to have cos of 73 times by 93. Cos of 73 times by 93. I think that, you can check your answers, we've got you 27.19, etc. Next one along. And we're looking at an angle this time, labelling the sides. I've got hypotenuse, and we've got the opposite. With the hypotenuse and the opposite, SOH, so we're looking at the sine version here. We are trying to calculate the angle, so we're looking at the inverse sine. Sine from -1 to opposite divided by hypotenuse, 6/11. I think that, if you've done that one, would have given you 33.05. We did have a couple of other people now writing down.
Yeah, there's a few people agreeing with D now.
Okay, right, let's have a look then, see if this is going to be the biggest answer for this one. I think it's Socoterra again. Does anyone mind writing what trig function you used, sine, cos, or tan, to be able to do D? To be able to do D, is it a sine, a cos, or a tan question?
We're getting a few tans.
Tell Finn just to come down here and sit in the back of the room.
Okay. I was just typing out a long message to him, but I'll.
Tan. Yeah, excellent. I agree. Pretty good, because we have got the opposite and the adjacent. Opposite and adjacent, of course, is tan. We're going to try and work out the adjacent. Does that mean it's a multiplying or a dividing question? Can you write in the chat again? Is it a multiply or a divide question? Yeah, well done, guys. Divide, absolutely right, because in this particular case, we are trying to calculate the adjacent, so I cover up the adjacent on my TOA there, and that does give us the opposite divided by the tan. So we would be looking at here 15 divided by the tan of 23. And type that in my calculator, 35.33, etc. And well done. If you had D, you were correct, because that was the biggest value of each of those ones. So really good. Right, okay. On to some 3D questions then. 3D questions are basically questions that are involved within either 3D shapes or are involved in a 3D or a real life scenario. So we're going to look at just the shapes versions today, and then we might be able to look at some more kind of 3D version type questions next time as well. So let's look at this one first. A, B, C, D, E, F, G, H is a cuboid. Okay, we've got a cuboid with the vertices labelled. And we've got the lengths of the sides of some of the edges, 10 centimetres, 6 centimetres, and 5 centimetres. The question says this: what is the angle between the line EC and the plane ABCD? Give your answer to one decimal place. Come in, Finn. Hello. You want to go and sit at the back? You got a calculator? Oh dear. Where is it? Upstairs. Have you got a scientific calculator on your phone?
If you turn it on your side, it normally comes up scientific on a phone. If you turn your phone on the side.
Yeah. He's gone again, by the way.
Okay.
Right, anyway, so here we go. Right, it's going to be helpful, I think, probably to establish what angle we're talking about here. The line E to C. Right, so E to C. Well, this is the diagonal, isn't it, through the middle of this cuboid. Okay, so we've got that diagonal through the middle of it. And then we've got the angle created by that line E to C, and the plane A, B, C, D? Well, the plane is the two-dimensional kind of sheet, if you like, which is the base of this cuboid. So it's this kind of base of the cuboid here, which is the plane of the base. In other words, what we're really saying is the diagonal to the floor of this, the base of this cuboid. It still doesn't help us be able to work out what the. Just left the door open, so I'm just going to close that. It didn't help us be able to work out where the angle is. Because is the angle here? Is it here? Is it? Who knows? There's still a bit of work we've got to do to be able to establish what the angle is. In actual fact, we need another line on here. The line we need is the line that goes from A to C. Because the angle that we're asked to calculate is actually this angle here between those two lines. In other words, it's actually the angle, realistically, using three letters, E to C to A. That's the angle we're being asked to calculate here. If you try and think of that as the room that you're in currently, and you thought about it from the top corner to the bottom corner, opposite corner, and the floor, then it hopefully makes more sense that that's the kind of angle of elevation that we're trying to calculate. Okay, right. How are we going to be able to calculate that angle? Well, we don't know any of the sides of that triangle, or do we? First step always is to draw out the triangle that's involved within the question. So I think that the triangle involved, I'm just going to draw it over here, is the one that's E in the top corner, down to C, the bottom right corner, and A in the bottom left corner. And I think that is a right angle triangle, because I think that here, if I draw my diagram now, that is a right angle along the floor, if you like, of this miniature room and then box, and then straight up the side, the vertical roof. But do we know any lengths of that side? E to A is 5. Yeah, nice. It's the opposite, isn't it? So it's the height of it's 5. Perfect. Spot on. We can write that on there straight away, can't we? Which one's easier to work out? E to.
Oh, we can also use Pythagoras to work out A to C.
Nice, really good. Actually, like teaching a proper class.
You got an assistant today?
He had actually, yeah, I can actually see he had a hand up in the corner over there.
Yeah, I was going to say, I hope he put his hand up.
Yeah. A to C, yeah, nice. This is going to use Pythagoras to get on the bottom. I think this is going to be the square root of 10 squared plus 6 squared. Okay? Then we're trying to work out this angle in here. We've got 11.66. Yeah, nice. I think I might keep that as an exact value for the time being. So I think the square root of 136. That makes sense? Yeah, I think so. So I can leave it like that now. Now we want to be able to work out this angle in here. And now we're going to be able to go to our subtower. And we've got the opposite and the adjacent. Opposite and adjacent, we're going to use TOA because that's got the opposite and adjacent in. And we'd like to be able to calculate this angle in here, which is the inverse tan of the opposite, which is 5, divided by the adjacent, which is the square root of 136.
Interestingly, Sir Lola's in the chat put AC is 11.66, and you've put AC as root 136.
Is that not the same thing?
Well, I was just thinking that a little bit like last week when we're going from one part to the next part, about how you've kept an exact form.
Yeah.
And Lola completely right, I believe, of 11.66, but actually the way to do it, yeah, and 11.66 is just a rounded version of root 136. But when we're using it to work out another value, it would be more accurate to keep it in third form, as you have done.
Well, let's do both things. type in, Lola, if you can keep your 11.66, and if you can type in for me 10 to the minus 1 of 5 divided by 11.66, like that. If I could get some other people to type in, and see if they can type in 10 to the minus 1 of 5 divided by the square of 136, and we'll see how much of a difference there is between those two answers. Is it significant? Does it not really matter? Or is it actually, if we're asked to round this, quite significant in the two answers? So let's go for Lola first. If you could type in that one, lovely.
Yeah, Lola's got us an answer.
Do you want to read that out to me, sir?
So I'll give it to 2 decimal places.
Give me quite a few more, actually, if that's okay.
Yeah, no, fine. That's
I'll be able to see whether there's a difference.
She's given us about 10, so that's good.
Yeah, go for it.
4.60.
Yeah.
75 26 44.
Okay, right. Now I know what the other one then, at the top here, don't I? The exact answer to see whether there's much of a difference between them. They're both going to be 64 point something.
Right, okay.
Here we go. Go on, if you read out that other one, I think we've got another one now, haven't we?
Yeah, so the other would be 64.
Yeah.
0.611.
Yeah.
9662.
Okay, lovely, thank you. Right, let's look at these two answers then. Now, if you are asked to round your final answer to the nearest whole number, they're the same, 65. If you're asked to round them both to the nearest one decimal place, they're both the same, 64.6. If you're asked to round them to 2 decimal places, this one becomes 64.61, and the other one actually still becomes 64.61. But 3 decimal places is 64.612 and 64.608. So yeah, it depends how you'd be asked to write your final answer, whether you're going to get full marks or you're going to lose a mark for your rounding there. Right, good stuff. I just want to point out one last thing. If you hadn't spotted that A to E was 5 centimetres, there may still have been a way of you being able to do this question, because you might have been able to work out what E to C was. So let's just have a little go at being able to work out the diagonal across the cuboid, because this is an important skill actually that you will need to have when you come to do this, some other questions later on in the moment as well. Right, I'm going to maybe draw out E to C. Well, yeah, maybe I'll just draw out that triangle again. Yeah, okay. Let's draw that triangle out again, the one we've just had at the top there. So we've got E, we've got the A, and we've got C. Maybe you thought, maybe you just want, the question was actually, you just wanted to work out the diagonal. So let's have a look. Maybe the question was different, and it just said, could you work out the diagonal E to C? So let's go for our value so far. This was the square root of 136. We've worked that out a minute ago. This one was 5. Can anyone give me the exact value in the chat of what E to C would be? Can you give me the exact value of what E to C would be?
We've got from Lola again, thank you Lola, and now Isabel, 12.6885 7754.
Is that the same as that root 161?
Let me have a look. Root 161. Yeah, that's the same as root 161.
Okay. I'd like someone to type in this as well. The square root of the squares of all of these 3 sides. 10 squared plus 6 squared plus 5 squared. Yeah.
Saying the same as before.
Hopefully people are noticing that actually it's the same as before. And this is quite nice because you don't have to kind of use Pythagoras twice to be able to work out the diagonal directly across the middle of a cuboid. Actually, the whole Pythagoras formula for 3D like this simplifies to, if I had a cuboid and we had for our cuboid the lengths x, y, and z, say, the distance across this cuboid from the top corner to the opposite corner, or any other diagonal, because all those diagonals are going to be exactly the same length each time, is going to be the square root of x squared plus y squared plus z squared in one go. And that's the diagonal across the shape is going to be equal to that. So that's quite a useful little skill to have, a little formula, if you like, to jot down maybe, because that's quite a quick way of being able to find the length of that diagonal if you need it, to be able to then either calculate it in one go or be able to use it in a future calculation. Right, one for you to do. I'm going to put a question on the board now, give you 5 minutes. I think there's a couple of parts to it. It's very similar. It's a cuboid, and then you've got to try and do a couple of calculations on it. So, this is the one for you to do. You've got a cuboid, you've got 3, 5, and 8 inches. You're asked to do a couple of things. You're asked to calculate the exact length of A to H. Well, just met something that's going to be pretty useful there, I reckon. And then you're asked to calculate the angle E to D to G. E to D to G. Maybe just to give you a bit of a help, I'll draw the lines on there. E to D to G, to help you be able to visualize that angle that we're talking about. Right, 5 minutes. See if you can get both answers. But don't put your answers in the chat straight away when you get them. Let's just give everyone an opportunity to see if they can do both part A and part B for that question. Whilst I go towards you.
Okay, we've got one answer, sir.
Okay.
I don't know. Did you want them in the chat yet, or?
I don't mind. I'm just going to check on what things here.
I find the length of A to D, A to G, so I can do an angle question.
Okay, that's right. No, because you did ask to work out A to H as well. So, are you doing the angle question? You're doing part B first, are you?
Yeah.
have you worked out?
So I think I know which one I'm meant to do with tan. I think I know what you
Yeah.
And then,
What have you worked out? The opposite of the adjacent?
yeah.
Yeah.
And I got some use.
Okay. Okay, yeah.
So I've got 9.9 for hypotenuse, 9.4 for the adjacent, and 3 for the opposite.
Yeah, so we're going to use them now to get the angle, aren't you?
Yeah.
Good. Right, we're well on our way here. So, should we have some answers? The exact, first of all, part A, the exact length of AH. Let's have that in the chat box now, please. The exact length of AH.
It's really very small.
So we've got 1 in decimal places.
Yeah, okay. I think you can pretty much, using that method before, you can always do this in your head, can't you? I reckon. Now we've got the exact value of A to H is the diagonal across, which is 3 squared plus 5 squared plus 8 squared. And if you don't want to do it as a decimal, it's just going to be that number underneath the square root sign. 64, add 25, add 9. Right, let's have a look. Okay, this is what I got. I thought I would do the square root of 3 squared plus 5 squared plus 8 squared, because from that previous slide, or the bit above there, we don't have to be able to work out 5 squared plus 8 squared square rooted, and work that out to get G to D, or whatever the diagonal on the base, and then do the same for the 3. We just do it on one go. Right, well, I got 7 root 2, which...
Let me have a go. 7 root 2.
9.89.
That's what the people are getting in the chat. The couple of people who've put.
Yeah, perfect. Really good. You could write that, I guess, as in in words as that. That would mean the same. I'd be happy rewriting that. Okay, like I've just put in the chat there, 7 root 2. Right, what about part B then? Well, we know the angle we're trying to calculate here, E to D to G. Let's have a go at what I've put on here. That was the one, E to D, had to be the same size as that diagonal that we just calculated for A to H. They're the same size diagonals. We've got that the G to E here is 3. And we've also got that base, which you could have worked out in the previous one, which would be 5 squared plus 8 squared, square root of 89. So now if you've got all 3, there's loads of different ways of doing this, isn't there? I maybe have got, did I see that answer anyway? No, I didn't. Anyway, I've got this one. Maybe I've gone wrong somewhere. Can someone else check this, see if I'm right? I got to either the tan of 3 divided by root 89. Yep. Or I got to the cos of the adjacent divided by the hypotenuse, which also got me to that 17.6 value. Or you could have sine to the -1, the inverse sine of something as well. Anyone like to put a hand up and tell me what you would type in to again get that same answer of 17.6 degrees? Anyone want to put a hand up and tell me maybe what you would type into that box? What's hidden underneath this box that I'm shaking around now to be able to get that still that same answer? Anyone want to put their hand up and just unmute themselves? Otherwise, Finn's going to take a real.
Oh, we might have one hand, I think. Yeah, Lola, she's doing brilliantly. She's answering everything.
Unmute yourself. What's going to go underneath this box here?
Is it 3 root 2 over 14?
3. You might. Oh right, okay. Is that, look at my triangle above here, Lola, if you can still see. I think you might have simplified it, which is absolutely fine. What's the opposite on my triangle? 3. Yep, that was right, wasn't it? Over 7 root 2, opposite divided by hypotenuse. I think you might have done a simplified version of that one, or a different version of that one.
Yeah, it is 3 root 2 over 14 simplified.
Is it? Yeah. So when you type that into your calculator, 3 divided by 7 root 2, it rationalised the denominator to give you, say again, sir?
3 root 2 over 14.
Yeah, lovely. Thank you, Lola. That's brilliant. Yep, really nice. And that's the same thing as that one as well. Right, well done. Thank you very much. Right, let's have a go at another one then. Okay, here's another one. It is, this time it's a square-based pyramid, we're told in the question. So we're in at cuboid so far. So let's have a look at this square-based pyramid question. We've got to do 3 things. We've got to find the exact vertical height. We've got to find the angle B to C to E. Okay. And we've got to find the angle AEB. AEB, which is one at the top. I'll label those in a second after we establish what the vertical height is. Right, well, the vertical height is going to be from the top at E, vertically straight down, because it's a square, it's going to hit the absolute midpoint of the base of that square. And that's going to be what we're going to call the vertical height. It's going to go down to the middle of this point here. Not quite lined up perfectly, so I'm going to have to put that there. Right, that's the height we want to try and calculate then. Okay. Well, we need to create a triangle, don't we? It's going to allow us to be able to work that out. I think this triangle I'm going to create here. Out to C, and then up to, back up from E to C. And I'm going to draw that one out. I think it's a right angle triangle. Finn's nodding. Just because I think we've got D is we're going along the base, D to C is the base, and then D to E is a vertical line. So I'm going to draw that out. Okay, D, C, E. And I put on any measurements that I know. Well, the only one I know, I think, at the moment is that one from E to C is 7. Finn.
A to B is 4 as well.
We do. A to B is 4. That's not on my picture, though, is it?
But it can help them. So, because you know that those, so A to B and B to C are both 4.
Yeah.
So you can use that to figure out what A to C is, and then you can have that to figure out what the middle of that is.
Sounds like a good strategy to me. Finn was saying that. I don't know if you hear Finn as well, sir, or not.
We've got root 57.
Did you hear Finn though when Finn's talking as well, or not?
Yeah, not incredibly clearly, but a little bit, yeah.
Finn's suggesting that this here is a right angle, 4 squared, square rooted, then halve it to be able to get what D to C is. So I guess longhand, that would be 4 squared out 4 squared. All of that divided by 2 would give us the length of D to C. Have you got that as an exact answer, sir?
I'll just do that now. So what's that? Root 32 divided by 2. So that's 2 root 2.
No. Agree?
Yeah, I think so.
Right, now we're just going to use Pythagoras, aren't we, to be able to finish the question, to be able to get from E to D here. So E to D, and over here now, is equal to the square root of, we'll find that shorter side, so to take away 1, 7 squared minus 2 root 2 squared. And we are asked for the exact vertical height, so we don't want any rounding error, and that's why we didn't write 2 root 2 as a decimal still. You there, Finn?
Yeah.
Go
I've got 3 root 5 as an answer, sir.
Yeah, if you get that, what have I done wrong then? I got root 41.
Root 41.
Root 57.
Yeah, no, you should have root 41, shouldn't you? because that's going to be 49, and 2 root 2 squared is going to be 8. So that would be root 41.
Yeah.
So I think I've gone wrong somewhere.
Did you, when you typed in your calculator, did you put a bracket around the 2 root 2?
That might be where I've gone wrong.
Yeah, it's honestly, that's quite, yeah.
We've
Because you're just squaring the root 2, not the other 2 as well.
We've also got a root 57, and I think, so that might be just that they've tried to work out the hypotenuse rather than the...
Yes, added them, subtracted. Yeah, that makes sense. Right, good stuff. Okay, so after we're happy, we've got that height, the vertical height there, the exact value is the square root of 41. Nice, 6 squared 36, 7 squared 49, 6 point something, right? But we want it as an exact height, so that's fine. Right, let's go on to part B. Part B asks us to work out the angle B to C to E. Right, my diagram's getting a bit messy here. Let's have a look. See if I can still put it on without looking too bad. B to C to E. Right, I think it's this angle here. Okay, B to C to E. Right, I think for this angle in here that we're trying to calculate, I think it might make sense to draw the isosceles triangle EBC out, first of all. And do that over here, E to B to C. Not a very good isosceles triangle, but it gives us the idea. So that's B, that is C, that is E, and the angle we're trying to calculate is this one over here. Right, we know that's 4 on the bottom. We also know that's 7 at the side there, don't we? But it's not a right angle triangle. We can only use SOHCAHTOA for right angle triangles.
You know, the isosceles triangles, the angles at the bottom are the same on both sides.
Yeah.
So we have a bit more information than they've given us.
Lovely. So what should we go for? Should we go for
And we
maybe?
can also figure out what half of the E is if we split the angle in half. So we know what. So we have a 2 and then a 7 of the hypotenuse. So we have to do 7 squared. Just square root.
Because we want this angle, then not the.
But then we can figure out what E is, and then we can double that to find out what the whole angle of E is. And we take that away from 180 the triangle is a bit apart. But then, and then we have that to figure out what.
If you guys can't hear this, this is literally just an individual lesson from me. I'm giving. Yeah. Right, pretty good then, but I think we can do it a bit easier. Yeah. I'm going to call that the adjacent. We're just going to focus on this triangle now. And I think that's an A for adjacent, that's the hypotenuse. So I think we can get back to this one, ACAH. I think we can get the adjacent. Oh, we want the because of the angle. So I think this angle here that we're asked to do for part B, BCE, is going to be equal to the inverse cos of the adjacent divided by hypotenuse, 2 divided by 7. Nice. Yeah, I can see I've got a couple of one correct answer at least there.
Yep.
We're asked one decimal place, 73.4 degrees. 73.4 degrees. Yeah, fine. Nice. Right, good stuff. What about the last one, part C? Well, part C asks us to work out the angle AEB. So A to E to B. Well, all of these isosceles triangles are the same, aren't they? So A to E to B is now, I can use the same triangle I used before. It's just going to be all of that angle at the top. That's 73, and it's an isosceles triangle. That's 73.4 here. That's 73.4. What are you going to do? Angles of triangle at 180, so I think 180 minus 2 lots of, that's 73.4 degrees. We don't want rounding error, so we want that exact value, but anyway, it doesn't matter too much. 1 decimal place, I'm getting 33.2 degrees. 33.2 degrees. I got that before, so I'm going to be happy that's the correct answer there. Could have done that in lots of ways. You could have gone back and worked out this little angle in here. That would have been okay. Inverse sine, but that's quite a nice strategy using our rules of angles in a triangle at 180 to get us to that angle as well. Right, okay. One for you to do. So this question is about a triangular prism. Yeah. Oh, no, actually, what I didn't do before. Oh, yeah, this was at the top here. I wanted to guess the extension. There's a question hidden underneath here. Anyone guess what that question hidden underneath there could be? He's been scratching his head. Just there to let everyone know. Any ideas? Can you type in the box what you think that extension question could possibly be? Could it be related to this prism pyramid? What are you guessing, Finn?
I was going to say something, but then it would be too easy.
No, go on. What are you going to say?
I was going to say it could be A to C to D, but that we already could figure that one out.
Yeah, so it could be another one. I'll give you a clue. It's not to do with trigonometry this time. It's not a length or an angle that I'm going to ask that you could be asked to calculate here.
I think I might have it, sir.
Do you reckon you might?
Yeah.
What is the shape called? Oh wait, no, it's only question.
Rex has said, how many faces has the pyramid got?
Perfectly good suggestion. Thank you, Rex, but it's wrong. Surface area, excellent suggestion.
Nice.
Still not right. Excellent suggestion, Freya. Any others? Freya's on the right track, just to give you even more of a hint.
Oh, I reckon I've definitely got it.
Ben?
Oh, it was Thomas as well. It was Thomas, not Fred.
Oh, that's a good thing. Got a good question. He said draw the net of the shape. It's not right, but it's a good one. Thomas, yeah, fine. Thomas trying to claim. Thomas, claim credit for right answers, not wrong ones.
Yeah, say it was Freya if it was wrong.
Yeah. It was. What's the volume of the prism?
Yes.
What's the volume of the prism? Now, you've not met this, but I will just tell you. When you've got a pyramid, the volume is equal to a third times the area of the base times by the vertical height. So we've got all the information to be able to work this out. Third times by 4 times 4 is 16, the area of the base, times by the vertical height, you have that one, is the square root of 41. I'm not going to ask you what the answer is, and I haven't got the answer, but you could type that into your calculator to be able to give you that answer. It's always a third. Whenever you look at pyramids, it's a third of the base area of the base times by the vertical height. Right, anyway, we digress. This is your question to have a go at. One thing to do. The triangular prism shown has got lengths of 10 from C to F. It's got A to B is 6 and D to F is 8. You are asked to work out the exact length of B to C. Okay. The angle E to D to F. E to D to F. Okay. And the exact length of D to C. Okay, going across there. Right, another 5 minutes then. See how many of those three you can get there.
That's fine, Dowie, don't worry.
What's that?
Dowie's laptop crashed, so we had to leave, but I'm just saying, doesn't matter. It's all good.
No, well, okay. Well, what have you got?
So I think I've got something to do soon. Starting at 5.29.
Yeah.
So I did the hypotenuse take it away.
Good. 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 Two more minutes. Has anyone finished all three yet? Your hand up if you finished all three. Okay.
Yeah, Lola's.
Yeah. Right, okay, I'm going to stop the timer then, and we'll talk about each of these ones. Right, Finn, start us off with A, please.
Do you want me to go through method or?
Yeah, method as well.
Okay. So, first I put all the lengths on my things
Mm-hmm.
to make it easier. So I knew what Dan line A to C was and what A to B was.
Yeah, A to C is 8. Okay, cool. And then what's the working with these two?
So I used Pythagoras, so I did 8 squared, which is 64, minus 6 squared, which is 36, which was 28, which I then square rooted to get 5.29.
Lovely. Sorry.
5.29 centimeters.
Was that the same as 2 root 7? 2 root 7. Yes, 5.29. So just be aware, Finn, that sometimes they ask you the exact length. When they ask the exact length, they want you to write it rather than decimal. They want you to keep that. Excellent, Finn. Thank you very much. Right, part B then. I'm going to go on to the angle EDF. E to D to F is this angle at the top here, and it doesn't seem to be too much to this, does there? Because we've got most of the lengths already. We could use that was a 6, or that was equal to 2 root 7. Probably best to use the 6 and the 8 there. 6 and the 8, inverse cos to give us 41.4 degrees for that answer. That one, 6 divided by 8. Jason, divide by hypotenuse. And the last one, the exact length of D to C. D to C, well, this is the length across the front here, isn't it? So it is a diagonal, but it's not a diagonal through the shape. It's still on one of the faces, that sloped face of that shape. Now that sloped face of the shape A, D, F, C, this sloped face is actually a rectangle, isn't it? So actually it's not too bad, is it? Because you've got a rectangle like that, 8 and 10, just Pythagoras again. 8 squared plus 10 squared to give you root 164 or 2 root 41, because again we were asked for the exact length rather than a decimal. Okay, Leanne, have you got all those right? Hans, have you got all those right there? Are you happy with those ones as we've gone through them?
Yeah, it's 6, 7, yeah.
And that Hans. Just to continue.
I'm going up now.
Brilliant. Right, really good. Well done. Right, should we just do one last one together then? Then I'll just explain the task to you for the week. Okay, before we get going. So this is a GCSE question. We'll just finish on this one. So we'll read it together first. Here's a pyramid with a square base. A, B, C, D. Looks pretty similar to the previous one. We've got the A to B is 5 meters. So the only difference here, they haven't actually written them on there. But we could write down A to B is 5 meters. That should be 5 there and 5 there and 5 there then, if it's a square base. We've got the vertex T is 12 meters vertically above the midpoint of A to C. Midpoint of A to C. And we've got that T is vertically above that midpoint. And we've got that is 12 in there. Lovely. And we're asked to calculate the size of the angle TAD. Okay, T to A to D. What is that angle there? T to A to D. Okay. Right, the kind of triangle we should be focused on is this kind of face. It's all getting quite messy already, but this face here, the triangle TAD, is certainly the one that's probably going to be the main part of our question. So let's just draw that out so we can see it a bit clearer. See at the top, A and D. Do we know any of those measurements yet? Do we know any of those measurements on that new triangle TAAD?
And we know the bottom one, which is 5.
Awesome.
And we know what T to the bottom is, which is 12, which might be used later.
Yeah, I'm not sure we do. I'm not sure that T, because that's T to the middle there, isn't it? Rather than T to the middle of that side, because that's a slanted face. I don't think we do necessarily know that one, but I think we might be able to work out what A to T is. Because I think we might need A to T, and to get A to T, we might need this triangle here to eventually be able to work out what I've just drawn on that main shape, to eventually allow us to be able to work out what T to A or T to D, either of those ones is going to be equal to. So, right, we're going to have to draw another triangle. This time it is a right angle triangle, isn't it? The one I'm focused on here, which is T at the top. This midpoint here, should we call this something? So I'm going to put that N, okay? To make it easier to see what's going on. I'm A over here. We know that's 12, that's the height there. What we'd really like to be able to work out is what A to M is, and then if we know what A to M is, then we can use Pythagoras again to be able to work out what T to A is, and once we've got T to A, eventually maybe we can get down to what this angle is. Pretty tough question, don't you think so?
Yeah, pretty tough, sir.
Right, any ideas how we can work out A to M? A Anyone fancy putting a hand up if they think they might have an idea of how to work out A to N?
Catherine Peel.
Yeah, I reckon she's just got a
Lola's been all over it this session. It's brilliant.
Catherine, do you want to unmute yourself? I've got a funny feeling she's accidentally left her hand up from before, so.
Right, okay. Should we go with Lola then?
Yeah, I like hearing from Lola.
Okay, Lola, if you want to unmute.
So I did the root. So I did Pythagoras.
Mm-hmm.
The root of 5 squared plus 5 squared.
Yeah.
Which equals 5 root 2.
Okay.
Do you want me to go through the whole question?
Yeah, keep going, Lola. This is great.
And then I did 5 root 2. Well, the root of 5 root 2 plus 12. Right, sorry, I mean the squared root of 5 root 2 squared.
Yeah.
Plus 12 squared. Which equals the root of 194.
And is that working out T to A? Do you think there, Lola? Does that give you? Yeah. Okay. So I'm going to put that on there for the time being. We'll see if that's we're actually right. Right. I'm going to pause there actually, Lola. Just mute yourself for a second, Lola. I might ask you to come back in a second. I like this. Is there anything, do you think, that's not 100%? This bit here, that 5 root 2, 25 out of 25, root 50, which is 5 root 2, I think that might be all the way along, from A all the way along to C. Let me check that on my calculator. Yeah, Finn's nodding in agreement there. So I reckon that's all the way across. So I think actually to get to A to N, which is this bit in here, we'd like to halve that first. So 5 root 2 divided by 2. It's that bit divided by 2. So we only get halfway across from A to N there. Right, so actually if we just put a square root of 2 in there, at the bottom here, for TA, I think then typing that in, with the brackets all the way across that, is then going to give us the right answer for T to A. For T to A. I think I might just type that in. And I'll see what I get. That. I'm getting the square root of 626 over 2. The square root of 626 over 2 for this value up here. Okay, right, well that is the TA, square of 626 over 2. This working with exact values all the time is quite hard, isn't it? Because, yeah, it's easy to get confused with it. Right, the last part then, we're after this angle. I think that in the bottom corner here, I think that we can create a right angle triangle now. I think we can call this 2.5 centimetres in here. And then the last part, given this length here, last question for me today is this one. This length here of this triangle, A to T, which we've calculated, given A to this part, this point here, is 2.5, would like me to use sine, cos, or tan inverse. Is it going to be sine, cos, or tan inverse, finally, to allow us to be able to work out this angle, the TAD angle? Write it in the chat. Last question. Is it sine, cos, or tan inverse to allow us to be able to work out this angle in here, given that I've got this side and this side of this right angle triangle? What do you got, Finn?
Cos.
Cos, Finn's gone cos. Yes, we've got another cos as well.
Got cos in the chat as well.
Lovely, loads of cos. Spot on, guys. Cos to -1, the inverse cos adjacent 2.5 divided by the hypotenuse, CAH, the square root of 626 over 2. Not very nice to type in. We can use our brackets to be able to get that. And 626 over 2. $78.5 degrees. Yes, really good. Well done. Excellent. I've got the right answer in there as well. Right, very nice, guys. Huge question. They're not that difficult for the homework. Let me just show you the work that I'm setting this week. So let's see if this is the right one. No, it's not. Let me have a look. 3D. Can you see my screen at the moment, sir? Like all the files and stuff, or not?
No, it's just the notebook.
Oh, is it? Okay, that's all right.
So if you go back to your one, I think I saw something.
Did you?
Yeah, I think so. To go down here.
No, that's just the file I'm on at the moment. Thanks for helping.
Trigonometry data in the side sheet, maybe?
No, it's not that one either. Right, it's on the BLE, but have a quick look. I think it's this one here. Yeah, this is the one. So how do I share this screen now, sir? Do I have to unshare and then?
Yeah, you have to. I'd unshare and then go back to share, and you do your screen or something like that.
Right. Is that any good? Can you see the 3D trig sheet now?
Yes, that's where we're at.
Yeah, so it's this is the one that's on the BLE, guys. You've got 1, 2, 3, 4, 5, 6, 7, 8. They're only one part of though. Okay, questions. In your books or on a piece of paper, show your workings out to get the right answers. Then you can use those are the answers at the bottom. They're all angles questions, these particular ones. Mark your answers, take a photo, and then submit that onto the BLE. Great. Anything else you wanted to add, sir?
Nothing from me, sir. Just I think my message last week about making sure that we have a good finish to the year and making sure we get everything done. So that I'm speaking to more than 5 people this time.
Yeah.
But yeah, just we've got a final 2-week push. So let's make sure that everything's being completed, and any issues, just email myself or Mr. Critchley.
No more live maths or anything this week, but there will be another one next Monday.
That'll be is there a timetabled one on Thursday as well, sir?
No, there isn't. No, that was last Thursday, wasn't it? You did one. It's only every other week, isn't it?
Yeah, as in next week. Is there?
Right. Sorry, next week. Yeah.
That'll be our last day, won't it?
That'll be the last day. Yes. So we might just do some answers on that last day.
Yeah, I think
maybe we could do a video or something like that on that last day.
Yeah.
Yeah, that'd be easiest, wouldn't it?
Yeah.
So we won't do a live one. Oh, will we? Or do we have to?
We'll do. I think we'll do the live one Monday.
Yeah.
Introduce the topic, and then either an answer session or a video of answers.
Yeah. Video on that last one. Yeah, that'd be a good plan. Right, sheet in for Friday this week, so I'm going to get marked over the weekend. We'll do another one on Monday, and we're going to look at exact trig values on Monday, which is really, really quite interesting, and where they come from. And then on Thursday next week, we'll just do the answers.
And then, sorry, sir, just to add on that when you submit your work this week, make sure you've you've marked the questions.
Yes. Very important. Thank you much. Thank you, Nine. Have a lovely evening. See you later.
Thank you, sir.
Thanks, sir.
Yes, see you later.